Hey guys, Jathan here with another video. Last video we talked about how to create a custom Arch installer that had ZFS kernel modules built in so that you could use it to either rescue an Arch system with ZFS or like we're going to do today, use it to install Arch on ZFS. So yeah, I guess I just gave that away. We're going to be installing Arch on ZFS. In particular, we're going to be installing our root on ZFS, but our boot partition will be on a traditional ext4, separate boot partition. And it's not because it has to be. Grub will support, not will, but does support booting to a ZFS pool directly, but it's a little dicey still, in my opinion. So ZFS, when you create a storage pool, has certain features that you either enable or disable for a given pool. And in particular, there's only a certain subset of those features that Grub will support booting to. So in my opinion, that means there's some room for breakage if ZFS adds some default features at some point, or Grub removes some features or whatever. I just think if you're still unsure about whether you really want to be using ZFS, if you really want to just do some testing, you don't need to worry about boot being on its own pool. The way that we're going to install today is probably the most sane, and I think it has the least room for error. So we're going to jump right in. I'm going to try to keep this, it's going to be a bit of a longer video, but I'm going to try to keep it as short as I can, I suppose. So on the left-hand side here, you can see that I am looking at my Vultr product page. So when you log in, more or less, this is what you see. I have a ZFS test system running already. We're not going to do anything with that. That's, I use that to prepare for this video and work on some content for future videos. But from the last video, we did end up with an ISO for our Arch installer. I've already gone ahead and added that to my Vultr account. Mine's called archzfs.iso. You can go ahead and add your own. You do have to have it on a file server somewhere, basically, like a public URL. We're not going to go through that, but just so you know, I already have it available. So we're going to go ahead to instances here, click Deploy New Server. We'll stick with Atlanta. Obviously, choose a data center that makes sense for you. Underneath server type, we're going to click Upload ISO, but rather than upload one right now, we have our Arch ZFS ISO available here. And then we are going to be stuck with using the $5 a month instance as the lowest. We couldn't use the 512 meg Vultr because we have to be able to unpack our entire Arch ZFS ISO, which is around 750 megs, into RAM. So this is kind of the bare minimum for this install method at least. We'll go ahead, enable IPv6, and we'll call this Arch on ZFS. And we'll deploy. So this is going to take a second. But essentially, as soon as it's up, we're going to open up the VNC viewer that Vultr provides. We're going to set a password for root and then enable and start SSHD. And that way we can just use our real terminal to log in, and we have better support for copying and pasting and all of that stuff. So you can see that was relatively quick. So I'm going to go ahead and click on this. Like I said, click on our VNC, and maybe it's not quite up. There we go. All right, so we're on our way. So like I said, this video we're going to talk about basically a traditional ext4 based boot. Obviously you could use XFS or something if that's what you're into. And then our root file system that houses our actual operating system and all will be on a ZFS pool, a single pool that we build. The next video will cover actually having a separate pool for boot that I refer to as a boot pool. So if you are interested in pursuing that, which there are some benefits to doing so, which we'll talk about in the next video, but definitely stay tuned. The other thing I'll just talk about while we're waiting for this for half a second is I have a couple of links up. So Vultr obviously is one of them. I have the install Arch Linux on ZFS ArchWiki page. There is a note at the top here, but I'll kind of just echo the same sentiment. If you try to just go through this and copy paste, you're not really going to end up with a working system. So just, you can go here. This is obviously a reference, but you can't rely on it solely. The general ZFS ArchWiki page, which is a wealth of information. You can see there's a lot of sections here. Super helpful. I used this quite a bit when I was developing this video. And then last but not least, this is the Arch ZFS package. This is the actual repo for the Arch kernel modules. We're going to basically use this because we're going to need their gpgkey, and again, I just wanted to bring it up, so I made sure I mentioned it so I could tell you guys, like, hey, these are the resources I used. So real quick, like I said, set a password for root. Obviously, this is just a password for the actual installer. It's not going to translate into your new running system, but still pick something sane. We are basically allowing root login to a fairly well-known IP on the internet, and then systemctl start sshd. And so now we should be able to close this. And if I copy the IP, ssh root at, and I'll paste that in, and then I'll just use the password that I set, and here we are. We're logged into our installer. So real quick, if we look with fdisk, we have a single disk, dev VDA. Obviously, if you're not installing on a Vultr, your disk naming might be different, stuff like that. So, don't try to copy paste what I'm doing verbatim. And again, we're not going to go through every single option that I'm choosing today when I create the ZFS pool. You'll notice when I actually get to the point of, CH rooting into my new Arch system, I'm not going to set the time zone or do anything like that. The purpose of this video is not to walk you through a super complete Arch install. Arch has great documentation for that already. It's to just cover things specific to Arch on ZFS. So my goal here is that you could end up with a running Arch system with ZFS, so that if you want to follow along with my future videos, or if you just want to learn about ZFS on your own and you happen to be an Arch user, you have the means to do that. So one other thing, before we get too far, it's always a good idea to make sure we can actually load our ZFS kernel modules. So I'm going to type modprobe ZFS, check the exit status was 0. Obviously, if this isn't working, everything else that we would be doing is kind of for nothing. So I like to check that at the very beginning to make sure there's no issue there. So we're going to jump right into partitioning our disk with fdisk. We're going to need 3 partitions. So because we're on a Vultr, they use basically legacy booting. They're not using UEFI. So we are going to use a GPT partition table. So we are going to need, first of all, a BIOS boot, or a BIOS boot partition. So we're going to go ahead and type N. Actually, before we do that, we'll make sure that we are using a GPT table. So we press G to do that. We press N, partition number, default of 1. This is our first one. First sector, we'll just press Enter. We'll make that 1 meg. It can be very small. It's just for Grub to put its core on, basically. We do need to change the type of it. So you'll see by default, created new partition 1 of type Linux file system. So we type T, and it already selected partition 1 because it's the only one for us. BIOS boot, I happen to know, is 4. And then we're going to type N for another new partition. Again, default partition number 2. First sector, we stick with the default. Last sector, we're going to say plus 512 MIB, 512 megs. This is going to be our boot. This one, we are going to format ext4, so keeping this as Linux file system is okay. And then we're going to make one more partition. So we can type N for new, partition 3 by default, first sector. If we just press Enter here, it'll automatically use the rest of the space available, so we want to do that. We do have to change the type of that one. This is going to be the partition that has ZFS on it, basically. So we type T. This time, because we have multiple partitions, it asks us which one to actually modify. So we say 3. And then we want to make this type Solaris root, which, again, I happen to have memorized, is 55. Like it says here, type L to list all. When you get to the point of changing your partition type, if you don't know the number for whichever one you want to actually use, you can just type L, and it will go ahead and list them all out. So now that we're done, we type W, And if we type fdisk-l dev-vda, we can now see we have a GPT disk label. We have one BIOS boot partition. We have one Linux file system partition. And we have one Solaris root partition. So that's nice. Great. We can jump right into making our ZFS pool right now. So for most of this video, I don't intend to copy and paste from the documentation over here, but this is kind of a longer one to create our pool, so I am going to copy and paste to make sure that, one, I don't make mistakes, and two, just to kind of keep the time down as much as I can. So we're going to copy, paste, and multiply. We're going to modify a couple things. Before we do that, we do want to take a look at our disk identifiers, and specifically, so obviously I have like dev-vda3 is my Solaris root. I could tell ZFS to use dev-vda3 as my device name, but if I do that, because the device names tend to change on reboot, or they can, when I reboot my system, ZFS is basically not going to be able to find the disk, and it's not going to work. So we always want to use UUIDs wherever we can. And since we're not using whole disks here, we're using partitions. Specifically, we want dev disk by part UUID. We want to grab the UUID for VDA3. So we just want to make sure we have this in our buffer for the next part. So I'm going to go ahead and copy in my command from the ArchWiki and change a couple of things here. So first and foremost, I like to run my Z pool with compression. So I'm going to go ahead and press enter here. Whoops. Apparently I can't actually do that to modify, so we'll just go O compression equals LZ4. You can see I'm just adding another option here. And then the last thing we want to do is, I don't like to call my pool zroot. My background is actually primarily in Illumos administration as far as ZFS goes, and they call it rpool, so that just is more familiar to me. So we're going to go rpool dev disk by part UUID. Like I just explained before, we want to make sure we're using UUIDs. In our case, we're using partitions instead of full disks. And then I'm going to copy and paste that identifier. And then last thing, I just noticed I spelled compression wrong. So I'm on a roll here. Okay, so again, I'm not going to go through all of these options right now. But this is a relative mount point because we're going to be installing our new system relative to mount. We're just telling it for right now that we want to make a relative mount point. Obviously compression, we want our whole pool to utilize LZ4 compression, which for what it's worth is the default for ZFS on Linux right now. A couple of other things, we want to make sure POSIX ACLs are enabled. For our root pool, assuming we're not breaking down our data sets into separate directories and such for logging and stuff, a lot of systemd logging requires ACLs, so we want to make sure that's set. So anyway, all right, we've made some progress here, so I'm going to press enter, and this time you can see I did not get an error because I actually, changed things I said I was going to change. And so just to verify that worked, I can go ahead and type zpool list, and I can see that I have my rpool with an alt root of mount specified. So for what it's worth, if you do want to learn about these different ZFS commands and some of the options and such, that will be a video just after these two install videos. Basically, I'm going to go over all of the ZFS commands and basic usage and such. So you won't be in the dark for too long. Anyway, so the next thing we're going to do, we have a pool, but we don't really have any data sets underneath this pool. So we're going to go ahead and jump right into creating them. And I think that's going to help you to kind of understand the relationship between file systems and pools. I do encourage you to look those types of things up if you're curious right now. But again, not the next video, but the one after, I will be talking about kind of ZFS basics. I'll explain all this terminology. I'll teach you how to interact with ZFS, do some basic ZFS maintenance and such. So anyway, ZFS create-o, mount point equals none. -o is just an option. I'm saying mount point equals none, rpool/data. So this is going to be a general place where we stuff basically anything that's not our file system, not file system, but our root is not a part of our core installation. So like home directories are going to go here. Things that if we wanted to roll back our file system, we wouldn't want to roll them back. ZFS create-o mount point equals none, rpool/root. This is where our actual operating system is going to go. More specifically, we're going to nest a couple of file systems under here, including one that we'll make now called default. Just making sure I get this right. So default, we're calling it default because this is going to be what we boot to by default. But because ZFS has snapshot capabilities, we might want to make one that's called, rpool/root/other, and maybe other is, from 2 weeks ago, and we would be able to roll our system back to what it looked like 2 weeks ago. ZFS create-o mount point equals home, rpool/data/home, and then we have ZFS create-o mount point equals root. So we can even make it so that our root home directory is still underneath our home mount. And that way we keep all the home directories, including roots, in one place. So I want to note something real quick. So when I just did these, ZFS by default, when you create a file system with a mount point, it will go ahead and try to mount them. So our alt root is specified as /mount. So if I go there right now, you can see that it did create 2 folders, and it most likely did mount these. So we can say ZFS get, I believe it's get mounted. Yes, right? So it says, yes, it's mounted. We don't want that to be mounted for what we're going to do next. So we can type ZFS umount-a. That's unmount all. And then we can rerun this command to get our mounted property. And you can see that it's now unmounted. However, it did leave these 2 empty directories behind. We want to go ahead and remove those because otherwise it's going to complain in a second. So obviously when you're running this RM, make sure you are doing it before you proceed and have your system and everything built, and make sure you're doing it in the right place. Okay, so back in root's home directory. So the next thing we want to do is we want to, again, we have our single pool here. I can type ZFS list now to see that we have some file systems underneath it. But in particular, we want to make sure that we can export our pool, which is basically a way of kind of detaching it so that it could be attached later to this system or another one, and re-import it. And the reason that's important is because essentially every time we reboot our system, it re-imports the pool. So it's kind of a sanity check that we can do very early on to say, can we actually re-import this pool without issue? And if so, that's a good sign. So we start by just saying zpool export rpool. And it's always good to make sure everything's unmounted before you try to export the pool, if at all possible. But because we just did the ZFS umount before, we're in good shape. And then we're just going to re-import it. So zpool import. We do have a couple of things here. So -d dev disk by part UUID. So this tells ZFS where to look for the disk identifiers that we gave it, right? And we're using partition UUIDs in our case. And then we still want to specify our alternate mount point. And then we specify our pool name, and then the -n flag, which just says don't mount any file systems. So it's going to import the pool with a relative path of mount, but it's not going to automatically mount any of our file systems with mount points. And the reason we don't want to do that right now is because we want to mount them in a kind of specific order. So first, we want to ZFS mount rpool/root/default. And then I think after that we should be able to just ZFS mount -a. I think it would have handled the ordering of that fine, but I like to just do it explicitly to make sure everything looks okay. So the other thing we want to do is we have to make sure we mount our boot partition because it is not going to be a part of our ZFS pool, right? So first we're going to make dir mount boot, Then we're going to verify with fdisk our boot partition is VDA2. So we're going to do makefs.ext4 dev VDA2. And then we're going to mount dev VDA2 at mount boot. And then there's one more step here that we can kind of do at any point in time, but since we're talking about boot right now, it's just where it kind of falls in line for me. There's a property of a ZFS pool that basically says, if you're using this as a boot device, where do I actually look for the file system? So we're going to say zpool set bootfs equals rpool/root/default, and we're setting that property on rpool. So hopefully after seeing me run a couple of zpool and ZFS commands, you kind of see the syntax. Zpool or ZFS set or get, then we have property equals, and then we have the name of the data set or pool. And then I think that we're in a pretty good place to go ahead and packstrap. So if I take a quick look at some mount output, it's quite long, but essentially we see dev VDA2 is mounted for boot. Rpool root default, which we just defined as our boot FS, is mounted on mount. So we're in good shape. So we're going to go ahead and run packstrap mount, and then we're going to do base devil or devel, depending who you are and where you come from. Obviously, you can choose for yourself. Like a lot of people would only include base. For me, it's kind of a habit to just include development libraries and such. Let's see what else. I want to make sure I have Vim. I'm probably going to want OpenSSH, and I probably want DH client, and I definitely want sudo. You'll notice here I'm explicitly not installing any ZFS packages, and I'm not installing a kernel, and we'll talk about that in a second. So I'm going to go ahead and just run this. So if you watched the previous video about building an Arch installer with ZFS kernel modules, you know that it's possible for the kernel to have been updated, but ZFS, Arch ZFS, to not be updated to accommodate that kernel yet, which is why I didn't include those packages in my packstrap here. So I can tell you, because I know based on, I have a couple running systems and such, that right now they're in sync. So when we try to install Arch ZFS Linux, it will just pick the latest kernel and it's not going to complain. However, if you get to a point where it basically says, I can't find the right version of Linux, the kernel, go ahead, watch my previous video, which I will link to in the show notes. Show notes, I'm so used to podcast. The notes for the video. And I will show you how to make sure you can get a matching kernel version to go with whatever version of Arch ZFS is current. So we can see that cleaned up. Next thing we want to do is genfstab, of course. And we always specify using UUIDs more or less. But immediately after running that, we're actually going to go ahead and edit that file. I'm going to show you why. So when we go ahead and open up that FS tab, what you see is genfstab very kindly put in a bunch of entries for our ZFS file systems here. And that might seem great, but ZFS actually handles the mounting of all these. So if we try to do it within FSTab after ZFS has already done it, we're going to go ahead and we're going to get errors. So the only thing that we really want to have in here is our sort of legacy boot partition. So we comment everything else out or delete it or whatever you want to do, save that file, and we're in good shape. So we're going to go ahead now, jump right into our chroot. So we're on the new system. What you can see is there's no longer a ZFS command, right? ZFS was in the sort of external installer environment, but now in the chroot we haven't installed ZFS yet. So first thing we have to do is prepare our pacman.conf with the actual ZFS repo, right? So this is another place, obviously I'm copy pasting from the Arch ZFS wiki because there's no sense in me typing all this out. What you're going to see though is if I go ahead and do that and try to update my databases, it's going to ask me to import the key, and 90% of the time, probably more, it's going to fail to do that, right? The whole gpgkey server situation right now is kind of a mess, so we're not going to go into details about why that fails, but they give you instructions here. Note if that fails to import, download, so we're just going to copy link address. We're going to download the key. We're going to do pacman key-a. We're going to add the key. And then we're going to do pacman, what in the heck is the directive? Pacman key, L-sign key, and then it's just the key there. Now we go ahead and do this. We can see it successfully updates. And then we want to do pacman-s, capital S, arch ZFS Linux. And again, this is automatically going to install kernel modules, our ZFS user space utilities, and then it's also going to pull in Linux for us. And we're just going to stick with make init CPIO today for our initramfs. And we go ahead and install all those things. So what you can see is, again, I am not going to set my time zone right now. I'm not going to set up any keyboard layout or anything like that. Typical things that you would go through in an Arch install. I highly recommend that you do on your system, but I'm just trying to keep the video to a reasonable amount of time. So I would say follow along with what I'm doing, but also keep the actual Arch install documentation up on the side and make sure that you are doing those things. So set your locale, set a time zone, install NTP and configure it is always a good idea. Obviously, you can do those things after your system is booted as well. I like to do them in the install, so I just kind of know that I'm good to go. But this just finished, so we're in really good shape there. There are a couple of other things that we have to do here. So first and foremost, I want to set a root password so I don't forget later. And that's so we can actually log into our new system once it's up and running. The other thing is our ZFS configuration has a couple more steps here, sort of. So essentially there are a couple of services that we need to enable and targets that we need to enable. So in systemd, targets are basically different states that our system enters at various points in time. They're not mutually exclusive, so you can choose multiple targets that have to be active or you want to be active or whatever. Before we do that though, we now have this utility called ZGenHostID, and we're basically going to feed it the output from the host ID command, and that's going to go ahead and write a file called ext4. And ZFS is going to use this in the cache file, and the cache file is where it sets some information about our pools. And so we're going to say ZFS set cache file equals etc ZFS zpool.cache, and we're setting this value for the R pool. You can do this, I'm pretty sure, in any order, but since the host ID does seem to go into the cache file, in my mind it makes more sense to do the host ID first. If you miss the step, your system will fail to boot when you're done with all of this, so don't forget to do it. Next step, we have to actually tell our kernel, or we have to add the kernel hook for ZFS. So etc make init cpio.conf, and you can see we have keyboard and file systems. I'm going to actually go ahead and remove keyboard, and I'm going to add it here. So keyboard, ZFS, and then file systems. The reason for that is if you were using ZFS with encryption and you used a password, an encryption key to decrypt your pool, you would have to have a keyboard specified first so you had that level of interactivity. So we go ahead, we save that file, init cpio-p linux, we rebuild our initramfs, and what we see now is it's actually running a build hook for ZFS, and actually it does them all in order, so we see keyboard, ZFS, file systems. That's good news. This is going to take just a second to finish up. Then we're going to enable all of the services and targets that I had just previously mentioned. Sorry, I kind of jumped out of order there. I don't know why I do any of the things I do in the order that I do when I'm doing an Arch install at this point. It's kind of funny because I think I do it pretty differently than most people. So this is just going to be a bunch of systemctl enables. So systemctl enable ZFS.target. Then we want to do systemctl enable ZFS import cache. Then we want to do systemctl enable ZFS mount. And then last but not least, systemctl enable ZFS import.target. Again, not going to explain what each of these is responsible for. This is the bare minimum in terms of any ZFS services and targets to boot the system. There are some others that we're not accounting for here, like the event daemon, which is for logging. We don't really care about that right now. In a future video, I might break some of these down and talk about what they all do and such, but for now, again, my goal is to get you a working system so that you can follow along with what I'm doing and continue to learn about ZFS with me. I'm pretty sure the last thing we have is to install a bootloader. So to the best of my knowledge, Grub is the only bootloader that actually supports having boot, like your /boot on a Z-pool. That's obviously not what we did here, but it is why I'm using Grub, because typically I would actually use systemd boot, but I'm using Grub because in the next video, when we do have a pool for our boot, we are going to be stuck using Grub, and I'm just trying to be kind of consistent here. So we've installed Grub. Now we run grub install target equals i36pc dev vda, and then we're going to see here grub make config -o boot grub.cfg. This is going to produce an error. So basically, we can see grub failing to get canonical path of dev, and then this is our UUID for our partition. This is some weird idiosyncrasy thing that I have found is the case when working with ZFS here. So we just go zpool vdev name path equals 1, and then we just rerun the exact same command. And it works totally fine. I'm pretty sure that's the only place you ever have to do this. Once you're in your live system, if you ever have to run a grub make config, you will have to do the same thing. This is all documented in the ArchWiki ZFS page. So if you forget about it, it's there. So I think that's it. We've rebuilt our initramfs already after changing our hooks to include ZFS. We set up our zpool cache file. We set a host ID. We enabled all of our services. So we're going to go ahead and exit the ch root. Then we're going to umount our sort of legacy boot. Then we're going to do ZFS umount-a. That will just automatically unmount everything else for us. This is very important. You want to make sure zpool export rpool. Because the system, basically the installer, is going to look like a different system than our new environment, we want to make sure we export the rpool so that it will be set up for a clean import when we go ahead and reboot. And then we could just type reboot here, but Vultr is going to just boot us back to our installer anyway, so better option is in our interface here, go ahead to settings, custom ISO, and then just click remove ISO, and it will take care of rebooting for us. And I'm going to try to catch it right at the right time. Yep, so here's our grub screen, so it's already rebooting. And you are going to see a little bit of an error, or it looks like an error here that says no pools available to import, but then it will just take you to a login prompt anyway. I think that there is some kind of bug currently where the ZFS services start in a weird order, but everything actually comes up cleanly. So I'm going to go ahead and log in with my root that I set, and you'll see zpool list, we have my rpool, ZFS list. You'll see that basically I have all my data sets here and everything's mounted properly. So just to verify, ZFS get mounted, rpool data home. Yes, it's mounted. That's great. So this worked on our first try, which, you know, obviously I expected that because I prepared and Wanted to make sure that this was a clean process so you could follow along. The one other thing I think is important to get you up and running, so I'm going to cover it real quick, is if I want to add a new user, what does that look like because of my data sets here? So we gave root explicitly its own file system. We probably want to do the same thing for a new user, right? So we're going to go ahead, user add Jonathan, and if we look at the etc password output, you can see home Jonathan is where it's supposed to be going. I didn't specify the -m option, so it didn't create a home directory for me, right? That's empty. So we're going to use ZFS to do that. So we just type ZFS create rpool data home Jonathan. And if we type ZFS list, we see that showed up. It automatically picked a sane mount point. And if I do ZFS get mounted rpool data home Jonathan, it is mounted already. The only thing is, because we did our ZFS create as root, it is not going to have the right permissions. So we want to say chown and then chmod 700. And so now if I switch user to Jonathan, I am in my home directory. I can touch a file. So obviously that adds a little bit more work for actually creating a user, because you can't really use the -m flag. But what it does mean is, you know, if I wanted to make sure that Jonathan wasn't going to use more than 2 gigs in his home directory, I keep talking about myself in the third person, I could say ZFS set quota equals 2G rpool data home Jonathan. And if I do a ZFS list now, you'll see the available space for this data set, this file system, is 2 gigs. So the flexibility here is awesome. Obviously we have quotas with other file systems too, but in my opinion not quite as nice as ZFS. Not to mention the compression. So if I start pumping some data into home Jonathan via an rsync or something like that, we're going to see that essentially it will compress it. So I'll actually be able to store more than 2 gigs. Not a whole lot. We're talking about pretty small numbers here. But in any case, thanks for watching. I appreciate your time. If you have any questions or comments, please leave them down below. Obviously, kind of still new to this scene, but trying to do my best to keep these as short as I can, clean, actually informative. If you guys want to see more videos like this, feel free to subscribe, hit the thumbs up button. Always hit me up on Twitter. It's @JRDemacy, and I'll see you guys around.